I am Archimedes of Syracuse, born around 287 BC in the Greek colony of Syracuse, on the island of Sicily. My father, Phidias, was an astronomer, and from him, I inherited my love for the natural world and the mysteries of the cosmos. My earliest memories are of watching him chart the stars, his instruments delicate but precise, as he measured the movements of the heavens. It was in these moments that my own journey of discovery began, and I resolved to understand not only the stars but the very laws that govern the world. Syracuse was a vibrant city, but I knew that to further my education, I would need to leave its shores. So, as a young man, I traveled to Alexandria in Egypt, where I studied under the great scholars of the day. Alexandria was the intellectual center of the Mediterranean world, home to the famous Library of Alexandria, where vast knowledge was stored on scrolls from all corners of the earth. It was there that I immersed myself in mathematics, physics, and astronomy, drawing upon the works of Euclid, who had already made significant contributions to geometry. In Alexandria, I met some of the most brilliant minds of my time, including Eratosthenes, who measured the Earth's circumference with remarkable accuracy, and Conon of Samos, an astronomer and mathematician with whom I developed a lifelong friendship. These years were formative for me. I delved deep into the principles of mathematics, driven by the belief that every problem, no matter how complex, could be solved with logical reasoning. After completing my studies, I returned to Syracuse, where I spent the rest of my life, devoting myself to research and invention. My mind was constantly at work, whether I was studying the properties of shapes, devising mechanical devices, or pondering the principles of physics. While my contemporaries were content with the existing knowledge, I sought to push beyond it, always looking for new ways to understand the world. One of my first great breakthroughs came when I was tasked with designing a ship that could carry large cargo and passengers. This was no small feat. Ships of such size often sank under their own weight or leaked heavily. But I devised a solution, the Archimedes screw, a simple yet ingenious device consisting of a helical screw inside a cylinder. This device allowed water to be drawn up from the ship's hull, preventing it from sinking. This same principle is still used today in various forms to pump water and other fluids. In addition to this invention, I developed war machines to protect Syracuse from potential invaders. Using my knowledge of leverage and mechanics, I designed enormous catapults and ballistae that could hurl projectiles over great distances. These machines would play a crucial role in my later years during the Roman siege of Syracuse. One of the most famous moments of my life came while I was contemplating a seemingly simple question posed by King Hiero II of Syracuse. He had commissioned a crown of pure gold, but suspected the goldsmith had cheated him by mixing in silver. The king wanted to know if the crown was truly pure gold, but without damaging it. I pondered the problem for days until, one afternoon, as I lowered myself into a bath, I noticed the water level rise. It was then that the solution struck me. I realized that the amount of water displaced must be equal to the volume of the object submerged in it. By measuring how much water the crown displaced compared to a lump of pure gold of the same weight, I could determine whether the crown was made entirely of gold or if it contained other metals. Overcome with excitement at my discovery, I leaped out of the bath and ran naked through the streets of Syracuse, shouting, "Eureka! Eureka!" which means, "I have found it." This experiment demonstrated the principle of buoyancy, which states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. Today, this is known as Archimedes' principle, one of the foundational concepts in fluid mechanics. Another concept that fascinated me was the lever. I was captivated by the idea that a small force could move a large object if applied in the right way. This led me to formalize the law of the lever, which states that the ratio of the distances from the fulcrum to the points of applied force is equal to the inverse ratio of the forces. In other words, a longer lever arm requires less force to lift a heavier object. This discovery was not just theoretical. It had practical applications in my inventions, particularly in the construction of machines for moving heavy objects. I once famously boasted, "Give me a place to stand, and I will move the earth." While this was, of course, an exaggeration, it captured the essence of the power of leverage. With the right tools and knowledge, seemingly impossible feats can be achieved. While my inventions and practical applications earn me fame, my true passion lay in mathematics. I spent countless hours exploring the properties of shapes, particularly circles, spheres, and cones. I discovered many relationships between these forms, and one of my greatest contributions was my work on the geometry of spheres and cylinders. I found that the volume of a sphere is two-thirds that of a cylinder that surrounds it, a relationship that filled me with pride. In fact, this discovery meant so much to me that I requested that a sphere and a cylinder be inscribed on my tombstone, along with the formula I had derived for their volumes. I also dedicated much of my life to calculating the value of pi, the ratio of a circle's circumference to its diameter. By inscribing and circumscribing polygons around a circle and calculating their perimeters, I was able to approximate pi with remarkable accuracy, establishing that it lay between 3 and 1/7 and 3 and 10/71. Though we now know that pi is an irrational number, my work laid the foundation for future mathematicians to continue refining its value. My life was not solely spent in quiet contemplation. In my later years, Syracuse found itself at war with Rome during the Second Punic War. The Romans, under the command of General Marcellus, laid siege to our city. Though vastly outnumbered, I used my knowledge of mechanics and engineering to devise several war machines that helped defend Syracuse. One of my most famous inventions during the siege was the claw of Archimedes, a massive crane equipped with a grappling hook. When Roman ships approached the city walls, the claw would be lowered, grab hold of the ships, and then either capsize them or lift them out of the water entirely, dropping them back with devastating force. The sight of their ships being plucked from the sea struck terror into the hearts of the Roman soldiers, and for a time, we held them at bay. I also designed large mirrors, which, according to some accounts, were used to focus the sun's rays on the Roman ships, setting them on fire. Though the historical accuracy of this story has been debated, it speaks to the ingenuity that I was known for. Despite our efforts, the Romans eventually breached Syracuse's defenses, and the city fell in 212 BC. Marcellus had given strict orders that I was to be captured alive, recognizing the value of my intellect. However, as the Roman soldiers stormed the city, I was deep in thought, working on a mathematical problem. A soldier entered my workshop, demanding that I come with him, but I, absorbed in my calculations, replied, "Do not disturb my circles." Enraged, the soldier struck me down, and so I met my end, not in battle but at the hands of an impatient man who did not understand the importance of my work. Though my life was cut short, my legacy endured. My writings, preserved by scholars, continued to inspire mathematicians, scientists, and engineers for centuries. I am proudest of my contributions to mathematics, particularly my work on geometry, pi, and the lever. My inventions, from the Archimedes screw to the war machines that defended Syracuse, demonstrated the practical applications of theoretical knowledge. My name, Archimedes, has come to symbolize the power of human ingenuity and the unrelenting pursuit of knowledge. Whether I was calculating the volume of a sphere, designing a machine to lift water, or defending my city from invaders, I sought to understand the fundamental laws of the universe and apply them to the world around me. As I reflect on my life, I see it as a constant quest for understanding. I was driven by curiosity, always asking questions and seeking answers through logic and reasoning. I believe that the world, no matter how complex, could be explained through mathematics and science. And though I may have been misunderstood by some, I find solace in the knowledge that my work has endured and continues to shape the world long after my death. Even now, centuries later, my ideas live on in the minds of those who seek to understand the mysteries of the universe, just as I did. I have left my mark on history, not through conquest or power, but through knowledge, an enduring legacy that will never fade.